All right, so what does absolute value mean? Somebody? Anybody? Blurt it out. Tell me something, kid.
It makes everything positive.
It makes everything positive, okay? That's what I expect you guys to remember. So if I wanted to graph the function y equals the absolute value of x, let's use the following numbers. Hold on. What did I say to use? -3, -2, -1, 0, 1, 2, and 3. So if I take the absolute value of each of these, what am I going to get for my y values in order? Go. 3, 2, 1, 0, 1, 2, and 3. Does everybody see where I'm getting these values from? I'm just making sure everything's positive because that's what absolute value does. Now, if I were to graph these points so I can get a feel for what the absolute value function looks like, it would be like this. -3, 3, bam. -2, 2, -1, 1, all right. 0, 0. And then look what happens as I go to the right. 1, 1, 2, 2, 3, 3. What kind of shape is being formed by this absolute value graph? It's sort of making this V shape, okay? It's similar to a parabola, but these are just straight lines, okay? It's like a V. So, think of this as the parent function of absolute value. So y equals the absolute value of x, that's the parent function. We're going to talk about, just like we did for parabolas, what happens when we add something on the end. What happens if we add something on the inside. And you're going to find that's going to be exactly the same as what would happen with parabolas. Okay, but this is a parent function. Notice that the vertex, and we still call it a vertex, the vertex is at the origin 0, 0. Okay, now keep that in the back of your mind. All absolute value functions are going to make a V. It's just a matter of where the V is going to be and whether sometimes it can be wider than this and sometimes it could be more narrow than this. And sometimes they'll be upside down, just like parabolas can be. Could you probably guess right now what would cause this to turn upside down? If there was a negative in the front. If I put a negative in the front right here, that would make this an upside down V. So those are the things to watch out for. But if I ask you to graph an absolute value function, at least you better give me a V. Now back to your notes though, we're just going to do sketches. So sketch with me. So we just did the parent function, absolute value of x. So what we found was, if that's my axis, then the absolute value of x just looked like this. So just make yourself a sketch. What was the vertex that we found?
0,
It turned out to be 0, 0, didn't it? Now, off in the margin, talk to me about the domain and range of this thing. Start with the domain. What's the domain of that graph? David, what's the domain? Yeah, okay, and you guys are scaring me with your silence because it makes me afraid you don't know. When in fact you do know. You better know. Did you know? Paige, did you know the domain was negative infinity, positive infinity? Excellent. Remember, the domain is how far to the left and right it goes. This goes to the left and right forever. I should really put some arrows on the end of this. So the domain would be negative infinity to positive infinity. All right. So it looks like I'm going to have to call on specific people all morning because you guys aren't responding as a class, and I need to know what's going on in your heads. So, Paige, let me start with you. Talk to me about the range. What would be the range of this graph? Yes. Now, switch that around and give it to me from least to greatest. Yeah. The range is how far it goes from bottom to top. Always give it to me in that order. So it's going to be 0 to infinity. Now, is this 0 going to get a rounded parentheses or a squarish bracket? Squarish bracket, because it touches it. It reaches the 0, no problem. So this would be how we'd write the range, 0 to infinity. Okay, now based on what you learned when we did parabolas, what do you think is going to happen when I add 3 onto the end?
Going up 3.
Isn't it just going to go up 3? Isn't that what you would guess? And you'd be right. Adding 3 on the end is just going to make the graph go up 3. So 1, 2, 3. And then it's going to make the V, as usual. Okay? So transformation from the parent function, I'm just going to write what Jesus said. It went up 3. Well, if it goes up 3, tell me, let's see, India, tell me what the new vertex is going to be. Isn't that going to be 0, 3? Because it's right there. It's up 3. So there's my vertex at 0, 3. Okay? Quickly, so the new domain and range. Okay, Denzel. Now I'm going to save you for the range. Yvonne, can you tell me the domain? Yeah, again, it's negative infinity to positive infinity. It still goes left and right forever. Denzel, talk to me about the range, brother. Sure, it's going to be 3 to infinity, because it starts at 3 and goes up from there. Okay? All right. Let's see. Miss Street. What's going to happen if I subtract 3 on the end like this? It's going to go down 3. So over here under transformations, I'm going to say down 3 compared with the parent function. So just make your sketch. 1, 2, 3. There's it's down 3. And then just make your sketch. So it should look something like that. Just move down 3. Okay. So Mr. Perez, what's the new vertex then?
0, -3.
So that's going to be 0, -3. Okay. Braylon, can you tell me the domain? Yeah, still negative infinity to positive infinity, right? Intervene, give me that range. -3 to infinity. Okay? Are you guys getting ahead of me because this is so easy? Or did you guys forget what happens on the inside? Let me see if Jessica knows. Yes. Do you guys remember adding a number or subtracting a number on the inside? That's your left or right motion. But, like Jessica just remembered, it works sort of the opposite of what you would think. So a positive 3 inside of there actually moves you to the left 3. Okay, so when you do your sketch, just make sure you draw it 1, 2, 3 to the left, like this. Okay? So that means, all right, Maritza, can you give me the new vertex? Just switch that around. Let's see. Well, because it's on the left, is this going to be positive or negative? Negative, okay. So we'll just make that one change. So this point right here is the point -3, 0. Okay, because it's left 3, up nothing. So -3, 0. Let's see, Jesus, give me the domain and the range, brother.
It's negative infinity, positive infinity.
Yeah.
Range is 0, infinity.
Correct. All right, so you're probably seeing that the domain of these absolute value functions is always negative infinity to positive infinity. So just worry about the range, 0 to infinity. Okay. That brings me to Mr. Gaines, my friend. What's going to happen when I do this, brother? Well, is it going to move up, down, left, or right? It's going to move to the right by 3. Okay, so compared with the parent function, the transformation is right 3. So make your sketch. 1, 2, 3. It's to the right. So there's our sketch. Very good. Sir, let's see. Piper, can you give me the vertex of this new one?
3, 0.
Perfect. 3, 0. Okay. Now, Mr. Clark, tell me the domain and range. Yep. Yes, but give it to me bottom to top. 0 to infinity. All right, domain and range always go least to greatest, so we'll go 0 to infinity. Okay, Andrea, can you see that this has two transformations happening? Can you tell me them both?
Left 3, down 2.
Correct. That 3 on the inside, that positive 3 sends us left 3, but then the negative 2 on the outside takes us down 2. So left 3 and down 2. So make your sketch based on that. Left 3, down 2. That means the vertex is about here, and it's going to do what it does. Okay? So Brent, can you tell me the new vertex? Yeah, left 3, down 2. That means negative 3, comma, negative 2. That's my new vertex. Okay? Notice, another way that you can look at the vertex. We did this when we did parabolas too. Everybody look at this, absorb this extra little piece of information. Remember the vertex? We used to look at this and say, it's always the opposite of this one, comma, this one. Okay? So if I look at a absolute value function, I could always just do the opposite of the one on the inside, and then keep the one on the outside the same. That's another way to look at finding the vertex. Okay, do we do domain and range yet? Nope. Okay, Evan, talk to me of domain and range.
Alright. Domain is negative infinity to positive infinity.
True.
And the range is negative 2 to infinity.
The range is negative 2 to infinity. All right, anybody having questions? It's pretty easy so far, right? Okay, so that was rough sketches. Now we're migrating over to more precisely graphing these things. It's a little bit more specific. Now, this is the parent function. Oh, I should have graphed it right on here. Well, we already graphed it, so I'm not going to graph it again. But, well, I guess I sort of can. We knew that the vertex was 0. Now, look. What was happening was it was going up 1, right 1. And then when we did the left branch, it was going up 1, left 1. Like this. Okay, so draw that graph right there. Now, what role does slope play in the absolute value function? You know, if we were graphing y equals mx plus b like we were doing yesterday, look, if this graph was just y equals 1/2 x, okay, I'm looking at this graph on the right. Let's see, Anoop, if I was just graphing y equals 1/2 x,
Yes.
how would I graph that, sir?
Your vertex is still going to be at 0, 0,
I would start at 0, 0.
and you would rise 1 and go over 2.
Right, based on what we were doing yesterday, we would start at 0, 0 because there's no visible slope, and then we would go up 1, right 2. Well, we can still do that, okay? That slope is going to still say up 1, right, up 1, right 2, like this. All right, I put that first dot in the wrong spot. Let me fix that. Now, what that does, though, is that gives us the right-hand branch of the absolute value function. So we've got the right-hand branch doing this. How will I find the left-hand branch if this is the vertex? How will I get the other branch?
Up 1 left.
Yeah, just do the mirror image, correct? If I went up 1, right 2, the left-hand branch better be up 1, left 2. So I can just do that. Okay? So the right-hand branch works like normal, but the left-hand branch is the mirror image of it. Okay? And that's basically how you graph an absolute value function. I'm just kidding about that being a sad part. All right. So looking at this graph right here, picture it just like y equals mx plus b. No, check that. Vertex. The first thing we have to decide is, what is the vertex? Okay? Now, look at the absolute value symbols. Is anything being added or subtracted inside the absolute value? No, it's just x. That means the x-coordinate of the vertex is what? 0. Okay, so I'm going to start off with an x value of 0. Now this number on the end tells me the y-coordinate of the vertex, doesn't it? So what's the y-coordinate of my vertex? 5. So my vertex is going to be 0, 5. Inside, outside. The -3 doesn't affect the vertex. So your first step should always be to plot your vertex. So Paige is going to go 0, 5. Okay, 1, 2, 3, 4, 5. So there's Paige's vertex right there. Okay? Now, Victoria, if I was just doing y equals mx plus b, where would I go from here? Correct. Okay, Victoria is looking at the -3. If this were just a line, that's the slope. So that would be like -3 over 1. So that's down 3, right 1. So from the vertex, yesterday we kept doing the y-intercept. Now we're going to always start at the vertex and go from there. But down 3 over 1, just like we did yesterday. Down 3 over 1, down 3 over 1, down 3 over 1. Okay, that gives me the right-hand side of my V shape. How do I get the left-hand side, everybody? Anybody? Down 3, left 1. Just do the mirror image to get the left side. So down 3, left 1, down 3, left 1, down 3, left 1. That's how we get our V. Everybody's going to draw a V. Nobody's going to draw a straight line. It's genius. Okay. Okay, that's how you do that. Okay, Hunter, tell me the vertex of the next one.
Going to be 2, -3.
He said 2, -3. That was super close. Can somebody correct him? It's -2, what? -3. So Hunter, remember, it's always the opposite of the one that's inside the absolute value.
Yeah.
But the one on the outside, we keep that the same. So -2, -3, that's my vertex. So here I go. So -2, -3. There's my vertex right there. Now Hunter, where will I go from here to draw the right-hand branch? Yes, okay. See how this time there is no number in front of the absolute value. That means look at this as a slope of 1. So 1 over 1 is the slope. So Hunter said up 1 over 1 from the vertex. He's correct. So starting from the vertex, we do this. And then Hunter, how will I complete the picture? Do I just keep going in a straight line?
No, you go left 1.
You go left 1, up 1. Okay, V it up from there. Okay, connect those lines and that's how you do it. Let me see how it works for me if I cheat. Well, that worked pretty well. Okay. Alright, so that's what that should look like. Try to get ahead of me if you can. Try to graph faster than I can. All of my talking slows me down. So you should be fast. Okay, David, tell me what the vertex is for this one. 1, comma 4 is my vertex. Everybody see that? So over 1, up 4. So there's my vertex right there, you guys. Tell me where to go from there, David.
Down to right 3.
Yeah, down to right 3 because of the slope. Alright, that slope gives you the slope of the right-hand branch. So down to right 3. Alright, that's all I had space for.
Then down to what?
Then down to left 3 for the left branch. So down to left 3, down to left 3. So those are all the points that will fit. So I will draw my V now. Okay, so that's what that one should have looked like. Questions so far? Okay, Irvine, tough one for you. Tell me what the vertex is for this guy. -1, comma 0, correct. Because there is no number outside, so that one's a 0. -1, comma 0, so let's put our vertex. That would go right here, correct? -1, comma 0 on the x-axis. All right. Braylon, can you tell me where to go from here? Up 2 over 1 with that slope happening. So up 2 over 1 to the right, up 2, right 1, up 2, right 1. Braylon, follow through. Tell me how to make the left side. Up to left 1, okay? Up to left 1, up to left 1. Okay, just V it up. And that's what that should look like. Just connect your lines. Okay, any questions so far? All right, was that the end of your page?
Yep.
Okay. So for this one, the vertex should have been 0, comma 3. So 0, comma 3 would be here. And then that negative sign means it's going to be down 1, right 1, like this. And just make the V. The next one, the vertex was going to be 0, no. The vertex is going to be 2, comma 0. Should be right here. The slope tells me down 1, right 3. Okay, just look up every now and then, make sure you're getting the same things I got. But stay ahead of me. Don't let me catch up to you. You had a head start. Alright, Kelvin, tell me the vertex for this one. Positive 1, negative 3. So I'll be right here. Where do I go from here, brother? Up 2 over 1. Okay. Alright, and then just V it up, V it up. No straight lines, right, people? Absolute value is always a V. check your answers as I'm going. Make sure yours are looking like mine. Okay, Jesus, what's the vertex for this one?
Negative 2,3.
Negative 2, comma 3. Good. All right, Marita, on this one, where will I go from here? Down 1 over 1, correct. And then mirror image, V it up. Okay, Paige, give me the vertex for this one. Good. -1, -2, and just tell me where to go from here. Very good. Up 1, up 3, V it up. Okay, street. Give me the vertex for this one. Excellent. 0, comma -1. Then just tell me where to go from here. Down to right 1, correct. Down to right 1. Mirror image. Okay, just glance up and check your answer to that one. Make sure you had it right. Any questions so far? Is this pretty easy? All right, so this is our last unit. So if we can get one more really good grade just to lock in our grades for this semester. Okay. All right, yeah, everybody stop and focus with me now. Forget about being ahead for a second. Because we're switching gears here on the back. Now I'm giving you the graph, and you have to tell me the equation. So I recommend starting with the vertex, you guys. So looking at the vertex here, let's see, where was I? Mr. Jones, can you tell me what the vertex of this is? Yeah, that's 0, comma, -2. Now, what does that mean in terms of an equation? What's going to be on the inside of the equation then? Well, I'll get the slope later. Remember how do we usually get the vertex from the equation? Okay. So, because there's a 0 for that x value, that means there won't be anything that I'm going to add or subtract on the inside. Remember, because that x value comes from what's being added or subtracted on the inside. So in fact, I don't even need to leave the space that I just left. So I'm just going to have absolute value of x, right? Now, what's going to be on the end? -2. That's the number that comes on the end of the function like that. So this would be your equation for number 1, you guys. Y equals the absolute value of x minus 2. Oh yeah, the slope. I didn't do the slope yet. Thank you. I'm making him. I was moving on too quickly. Now the slope. After you get the main part, then you have to look at the slope. Focus on the right-hand branch, because that's the one that should match. So looking at the right-hand branch, since Victoria helped me, let me ask you. What is the slope of the right-hand branch? It's 2. Because it goes up 2 over 1, up 2 over 1. So the slope is 2 over 1, which is just 2. That means we need to have a 2 in front of that absolute value. So there's the equation. Y equals 2 times the absolute value of x minus 2. So do the vertex. That tells you what goes inside and outside. And then do the slope. That's the number in the front. Okay. Practice that. So, Irvin, my friend, can you tell me the vertex of number 2, buddy?
Vertex
The vertex is negative 2 comma 0. Now, can you tell me what that means in terms of what's going to be inside the absolute value and outside the absolute value? X plus 2 on the inside, and then nothing on the outside because it's a 0. Now, how do I know the number that's going to go in the front, my friend? The slope of the right-hand branch. Can you tell me what the slope of the right-hand branch is?
1 over 1.
Yes, okay, he said 1 over 1. Now, is this going to be positive or negative? It's negative, okay? So it's like negative 1 over 1, you know what I mean? And what does that just reduce down to? Just negative 1. Now, am I going to put a negative 1 right here in the front then? Just put a negative sign. We don't put the 1. Even though it's negative 1, we just put the negative sign. The 1 is understood. Did you guys follow that? Okay. Secret number 3. All right. Kelvin, tell me the vertex, brother.
Negative 1, positive 3.
-1, +3. Okay? Now, what does that mean inside and outside of the absolute value?
X minus 2.
Well, start with the x value. What's the x value I have here? Now, do I keep it the same or do I do the opposite? I do the opposite. So what's going to be in here? X plus 1. Okay? Now I come to the y value. That tells me what's going to go outside. So what am I going to put out here? +3. Now, brother, how do I know what goes in the front? Slope. The slope of the right-hand side. Can you tell me what the slope is? It's 1 over 2. Now, is that positive or negative, brother? It's negative. You see it's downhill. So what am I going to put in the front? -1/2. Okay? So here's the equation for number 3 right here. Y equals -1/2, absolute value, x plus 1 plus 3. Okay, are you following? Is everybody following? Okay. Brip, brip, Hunter. Give me the vertex, brother.
One,
1, -2. All right, tell me what that means in terms of writing the equation.
I just tell you
Leave the extra number in the front for the end.
in the absolute value of x minus 1,
X minus 1 from the plus 1,
outside minus 2,
outside -2. Now tell me what goes in front.
1/3.
You said in the front it's going to be 1/3 because of the slope. Up 1 over 3. Do I leave it positive or should there be a negative sign on that? Leave it positive. All right, it's an upward facing V, so we know it's going to be a positive slope. All right. Let's see. Jesus, tell me the vertex, brother.
0,
0, 0. What does that tell you about the equation, friend?
X.
Anything on the end?
No.
No, because they're both 0. All right, what goes in front?
Negative 1/3.
In the front will be -1/3. The slope of the right-hand branch is... Oh, wait a minute. We have that backwards, okay? Looking at the rise and the run, see how it's down 3 over 1, right? So that's like -3 over 1, which is like -3. So we just have to turn that upside down. Does everybody see why it's -3 as opposed to -1/3? Rise over run. Does that make sense, Jesus?
Yeah.
So that's the equation for number 5. Y equals -3, absolute value of x. Okay, Maritza. Last one. Can you give me the vertex first?
1, 2.
1, 0. Okay. Now, when I go to make the equation, can you tell me what I'm going to have on the inside? Right, okay. It's always the opposite on the inside, so minus 1. Anything on the outside? No. Do I need a number in front? Can you tell me, let's see, what's the slope? It's a little bit hard to see. Let me draw some dots to make it more clear. So, let's see. Yes, this graph is going up 3 over 2 for the slope. So I heard you say 3 over 2. So that would be your equation for number 6. All right? Any questions about it?